Hello there. We are back covering section 10.6 from Blitzer's Introductory and Intermediate Algebra for College Students. My name is Professor Shannon Gracie, and I will be your hostess this evening. Okay, so in 10.6 we move now to radical equations. As I mentioned before, we're going to be using the formula for squaring a binomial sum and a binomial difference. So you're going to need to get used to that. That is how I will show these problems. So if you need to look that formula up, please do. I can also write it up here again if you need to reference it. A plus b, the quantity squared, is equal to a squared plus 2 times a times b plus b squared, and a minus b, the quantity squared, is equal to a squared minus 2 times a times b plus b squared. We also, that's mostly what we'll be using. Okay, so why don't you go ahead and pause the movie and solve this quadratic equation and see how you do. Good luck. Okay, let's see how you did. On this one, we have a quadratic, so we need to get 0 on one side. So to do so, subtracting 5. I'm not going to be able to show every single step as we go along, but since this is a warm-up, I figure I'll help you out, hold your hand a little. So we get an equivalent equation here. Now, factoring by grouping is the way to go at this kind of situation. You have an overall product of negative 10. That's from doing the 2 times the negative 5. And you have a result of negative 3 when combining like terms, which will consist of two numbers with opposing signs. So the two numbers that fit the bill are negative 5 and positive 2. They have a product of negative 10 and they combine to be negative 3. So rewriting this guy, we will have 2x squared minus 5x's plus 2x's. So I rewrote the negative 3x as negative 5x plus 2x minus 5 is equal to 0. Factoring an x out of the first two terms, I'm left with the 2x minus 5. And then if I factor out a positive 1, I'm left with the 2x minus 5 again. Now I have a common binomial of 2x minus 5, and what I have remaining is x plus 1. Using the zero product principle, we have 2x minus 5 is equal to 0, or x plus 1 is equal to 0. Adding 5 to both sides on the first linear equation in one variable, we get 2x is 5. And dividing both sides by 2, we get x is 5 halves. Over here, subtracting 1 from both sides, we get x is negative 1. And then if we go to check our results, we will have x equal to 5 halves. So in the original equation, we would have 2 times 5 halves, the quantity squared, minus 3 times 5 halves. Is that equal to 5? So this would be 2 times 25 fourths minus 15 halves. Is that equal to 5? 2 goes into itself once, into 4 2 times. I now have the common denominator. So 10 halves, is that equal to 5? 5 is equal to 5. That checks out. And let's see, x equals 1 will be a little easier. It might get a bit scrunched. For x equal to 1, we would have 2 times 1 squared minus 3 times 1. Oh, my apologies, it is negative 1. X equal to negative 1. And then we're looking to see is that equal to 5. So negative 1 squared is positive 1. So we'll get 2 times 1 plus 3 is 2 plus 3. Is that equal to 5? 5 equals 5. So that one also checks out. So therefore, don't forget to present your solution of negative 1 and 5 halves in your roster notation. Okay, how'd you do? Awesome. All right, so moving right along. Solving radical equations containing nth roots. So here we go. If necessary, arrange terms so that one radical is isolated on one side of the equation. Raise both sides of the equation to the nth power, whatever your index is on your radical, you raise both sides to that power to eliminate the nth root. Solve the resulting equation. Now, a lot of times you're going to end up with a quadratic, right? So you're going to have to use all your earlier skills, problem solving and equation solving skills in these problems. If the equation still contains radicals, you have to repeat, you have to simplify and then repeat steps 1 and 2. And then this is very important. You do need to check all proposed solutions in the original equation. Many of these problems end up in extraneous, with extraneous answers or solutions. So they work out algebraically, but they don't check. So it's easy to get problems like this wrong by not checking. Okay, so here we go. Example 1, solve. So we have a square root equal to a constant. So in order to get rid of the radical, we will square both sides of the equation. So in this problem, the radical was already isolated. So once we square that, we will get 5x minus 1 equals, good, 64. Adding 1 to both sides, we'll get 5x is equal to 65. And then when I divide both sides by 5, I get x is equal to 13. So before I get all excited and keep that, I'm going to check. So we had just one solution of x equal to 13. So we check it in the original. Is the square root of 5 times 13 minus 1, is that equal to 8? So this would be 5 times 13 is going to be 65. Is that equal to 8? Square root of 64, is that equal to 8? 8 equals 8, so it checks out. So we now present our solution in roster notation of 13. Okay? All right. So what about part B? Let's check it out. When we subtract 11 from both sides, we get an equivalent equation of 2x plus 5 equals negative 5. What do you think about that? What is the domain, or the range rather, of a radical equation? The range goes from 0 to infinity, right, of a radical equation? Or you can think of it as, is there any way that any value multiplied to itself has a negative value in the real numbers? No. So this is not possible. So there's no solution. Now, if you were to work all this out, if you were to square both sides and everything, you would get an answer, but what would happen is the answer wouldn't check out. So here, our result will be the empty set. You can write it as the empty set, or you can say the null set. These are both equivalent. Just remember, don't ever put the null set inside the empty set. That can mean something else. Okay, so here we go. Moving right along. So part C, we have x equals the square root of 6x plus 7. So again, we square both sides, and we get x squared equals 6x plus 7. So now what's going on? Good, very good. We have a quadratic, so we need to get 0 on one side. So if we subtract 6x and if we subtract 7 from both sides, we will have x squared minus 6x's minus 7 is equal to 0. Okay. So now we need to, we need to factor. So here, x, we need, two numbers that multiply out to be -7, and when we combine like terms, we get -6. So I think x minus 7 times x plus 1 fits the bill. So we have x minus 7 equals 0, or x plus 1 equals 0, x equals 7, or x equals -1. So, checking our results. For our first answer was x is 7. Our original equation, 7, is that equal to the square root of 6 times 7 plus 7? 7, is that equal to, 6 times 7 is 42, so we would get 49. 7 equals 7, so that checks out. And then we also have x is equal to -1. We're checking this one. Is -1 equal to the square root of 6 times -1 plus 7? -1, is that equal to, that would end up being the square root of 1. So -1, is that equal to 1? Not unless you've been drinking, right? So here we go. This is extraneous, which means it worked out algebraically, but it's not one of these solutions. So we have found the only solution for x that works is x equal to 7. Okay. So the first couple problems have been square roots. Part D is a cube root. So a cube root, an odd index, doesn't have the same restrictions that an even index does, meaning that if a person were to get a negative on one side and the radical isolated on the other side, it would be okay if the index, right, the root is odd. If the index is even, at this point, we need to, since we're working in the real numbers, we would not have a solution if we had a radical with an even index on one side and a negative number on the other, as we saw in part B. So this one, what do we do first? Good, isolate that radical. So the cube root of 4x minus 3 equals +5 when I add 5 to both sides. Now, the index on the radical is 3, so I need to raise both sides of the equation to the third power. So this will give me 4x minus 3 is equal to 125. Now this one is a linear equation in one variable. So I get the variable terms on one side and I get the constants on the other. So adding 3, I will get 4x is 128, and then dividing by 4, I will get x is equal to 32 2. So checking our solution, we will have, is the cube root of 4 times 32 minus 3 minus 5, is that equal to 0? So cube root, this would give us 128 minus 3 minus 5. Is that equal to 0? Cube root of 125 minus 5, is that equal to 0? 5 minus 5, is that equal to 0? 0 sure is equal to 0, so that one checks out. So our result at the end of the day is 32. How we doing? I know it can get really tiring to check the results, especially with the problems that we're going to start working on the next page. They're a wee bit challenging. But you know, just hang in there, go step by step. If you need to replay, you know, what I do on the video, go ahead. Yeah. Okay, so here we go. We need to move one of these radicals to the other side, right? So might as well just move, you know, negative root 3x plus 7. So I'm not going to show this on every problem, but I'm doing it for the first problem. So we're going to end up with root x plus 2 is equal to 1 minus the square root of 3x plus 7. We okay with that so far? And let me just line it up so you can see. It zeroes out on the left side and we get 1 minus the square root of 3x plus 7 on the right. Now, whenever you have two radicals like this and you have one term that's not a square root, you're going to end up having to square both sides of the equation at two different times during this process. So we're going to end up with x plus 2, squaring that side. Now here we have a binomial difference being squared. So this is going to be 1 squared minus 2 times the product of the ends. So I'm using that formula that I told you to learn. And then the square of that right end. So we'll get x plus 2 equals 1 minus 2 of these root 3x plus 7s. And then when I square a square root, I just get the radicand. Now I need to get, you know, work with this so that I isolate the radical again, the radical term anyway. So I'm going to go ahead and I'm going to add the radical term to both sides. So I'm going to end up with 2 times the square root of 3x plus 7 equals. So I added that to both sides. I'm going to have the 1 plus 7 is 8. Okay? And then I'm going to subtract an x and subtract a 2 from both sides. So I'll write that out. So I subtracted 2 root 3x plus 7. No, I added, my apologies. All right, so I'm adding 2 times root 3x plus 7 to both sides. And then I'm going to subtract an x and I'm going to subtract a 2. So I'm working horizontally here. So negative x plus x is 0 x's. Negative 2 plus 2 is 0. And when I simplify on this side, the radicals zero out as we planned. 1 plus 7 is 8. 8 minus 2 is 6. And then I'm also going to have some variable terms. So I'll have 3x's minus x is 2x's. So I have 2x plus 6. So once I combine everything, so these guys not those two. So these guys zero each other out in case you're having trouble seeing it. Okay, so here we go. If I multiply both sides by 1/2, okay, then the 2's will divide out on this side, and I'll just end up with the square root of 3x plus 7. When I distribute the 1/2, I'll get 1x plus 3. Squaring both sides, so now it just becomes another, radical problem. I'll get 3x plus 7 is equal to x squared plus 2 times x times 3 plus 3 squared. 3x plus 7 is x squared plus 6x's plus 9. And then I have a quadratic. I need 0 on one side, so I'll get 0 on the left side. 0 is going to equal to x squared. 6x minus 3x is plus 3x. And then 9 minus 7 is plus 2. And we'll have 0 equals, this factors as x plus 2 times x plus 1. So we'll get x plus 2 is 0, or x plus 1 is 0, using the 0 property. So x is -2, or x is -1. So now we need to check our results. I'll just come up here for the check. By the way, I am looking for this process that I've been writing. Guess and check doesn't fly with me. So on the, on the exams, I'll be looking for your process, your equation solving process. So no trial and error. Okay, so if I check in the original, let's check x is -2 first. So the square root of -2 plus 2 plus the square root of 3 times -2 plus 7, is that equal to 1? -2 plus 2 is 0, so I'll get 0, and then plus root 1, is that equal to 1? 1 equals 1, so that one checks. When I check x equals -1, we'll see what happens. The square root of -1 plus 2 plus the square root of 3 times -1 plus 7, is that equal to 1? So I'll get root 1 plus root 4. Is that equal to 1? I don't think this guy's going to work, because we'll get 1 plus 2. Is that equal to 1? Not unless you've been drinking again. Remember, no drinking in math. So this is extraneous. So we've tossed that solution out, and we just keep the x is -2. And I don't know if I showed us crossing out the other extraneous one. I think we had an extraneous one up here. And I think that I didn't. Let's go ahead and show that we threw this one out. Okay. Okay. How are we doing? If you can conquer these problems, you're like a math stud or studette. Okay, so here we go. At least we only have one radical on part F. So let's take a look. We need to isolate the radical. So if we subtract 4 from both sides, we'll get 2 times the square root of x minus 3 equals x plus 1 minus 4 is x minus 3. And then why don't we just go ahead and square both sides right now. Be careful, you need to remember to square the 2 as well. So that's 2 squared times root x minus 3 squared. So we'll get 4 times quantity x minus 3 equals, and again, x squared minus 2 times x times 3 plus 3 squared. So we'll get 4x minus 12 is equal to x squared minus 6x's plus 9. We want 0 on one side, so if we subtract 4x and add 12 to both sides, we'll have x squared minus 10x's plus 21. And then that one's not so bad to factor. We'll get x minus 7 times x minus 3 is equal to 0. So x minus 7 equals 0, or x minus 3 equals 0. So x is 7 or x is 3. Now let's check our result. Our results. So when we check x is equal to 7, we have 2 times the square root of 7 minus 3 plus 4. Is that equal to 7 plus 1? So 2 times the square root of 4 plus 4, is that equal to 8? 2 times 2 plus 4, is that equal to 8? 8 equals 8, so that one checks out. And then if we check x equal to 3, we have 2 times the square root of 3 minus 3 plus 4, is that equal to 3 plus 1? So this will be 2 times 0 plus 4, is that equal to 4? 4 does indeed equal to 4, so that one checks out. So then we put our solutions in roster notation, and our solutions were 3 and 7. Okay. All right, part G. You know, this one might look a little bit awful, but you have something to the 1/3 power on each side. So I don't know if you want to just go ahead and put it in radical notation. It's up to you, so that it looks more familiar to what we've been doing. But this would be 2 times the cube root of x minus 1 is equal to the cube root of x squared plus 2x's. Then you would cube both sides to get rid of the cube root. And again, be careful, you're going to cube that 2 as well. So you'll get 8 times x minus 1 equals x squared plus 2x's. 8x minus 8 equals x squared plus 2x's. We need 0 on one side, so we'll just get it on the left. So we have our x squared, 2x minus 8x is minus 6x, and then we'll be adding 8. And then factoring, we get x minus 2 times x minus 4. So x minus 2 is 0, or x minus 4 is 0. X equals 2, or x is equal to 4. And checking our answer, we have, let's see, we'll do x equals 2 first. So 2 times 2 minus 1 to the 1/3. Is that equal to 2 squared plus 2 times 2 all raised to the 1/3? So 2 times 1 to the 1/3, is that equal to, that's going to be 8 to the 1/3. Well, 1 to the 1/3 is just 1, so we'll get 2. 8 to the 1/3 is the cube root of 8, which is 2. So that answer checks out. When we check x is equal to 4, we will have 2 times 4 minus 1 to the 1/3. Is that equal to 4 squared plus 2 times 4 raised to the 1/3. So we get 2 times 3 to the 1/3. Is that equal to, let's see, 4 squared is 16. 16 plus 8 is 24. So we get 24 to the 1/3. Well, 2 times the cube root of 3. Is that equal to the cube root of 24 is 8 times 3? So we can bring a 2 out of there, and we get 2 times the cube root of 3 is indeed equal to 2 times the cube root of 3. So that one checks out. It's a little nastier of a check, but it still checks out. Okay, so both answers work. We put them in our roster notation. All right, so here we go. So just a little bit of an application. Ooh, we reached page 100. Awesome. I mean, including the cover page, I guess. So here we go. If f of x is equal to x minus the square root of x minus 2, find out all values of x for which f of x equals 4. So what are they really telling us here? Good. They're telling us that they want us to put the function value equal to 4. So we would have 4 equals x minus the square root of x minus 2. And then we need to solve that equation. So what do? Good, we get the radical isolated. So we can just go ahead and subtract x from both sides. We get 4 minus x equals negative root x minus 2. The negative will go away in the squaring. So we square both sides, and then we will have 4 squared minus 2 times 4 times x plus x squared equals x minus 2. 16 minus 8x's plus x squared equals x minus 2. Getting 0 on the right-hand side and putting everything in descending order, we'll have x squared. We're going to be subtracting an x, so we'll have negative 9x. And then we'll be adding 2, so we'll have plus 18. And that's equal to 0. Factoring, we will have x minus 3 times x minus 6. That's all equal to 0. So x minus 3 equals 0, or x minus 6 equals 0. X is equal to 3, or x is equal to 6. So now we still have to check our solution. So there's a couple different ways, you can check it. You can evaluate the function at these values and make sure you get 4. Or you can just go from the equation we wrote. So I'm just going to go ahead, what the heck. Let's check it out. So f at 3. Remember, we want this to have an answer of 4. And if it doesn't, we'll throw it out. So f of 3, is that equal to 4? So what is f of 3? F of 3 is equal to 3 minus the square root of 3 minus 2. F of 3 equals 3 minus root 1. f of 3 equals 3 minus 1, right, which is 2. So this one is extraneous. It didn't work out because we wanted 2 is not equal to 4. Okay. So now, is f of 6 equal to 4? Well, f of 6 equals 6 minus the square root of 6 minus 2. F of 6 equals 6 minus root 4. F of 6 equals 6 minus 2. So f of 6 does indeed equal to 4. So we're throwing out x equal to 3 and we're keeping x equal to 6. We were asked to find all values of x for which f of x was equal to 4. So we'll just go ahead and put it in roster notation. 6 is the only value that works. Okay. So remember, all of this over here was just a check to verify. So this one checked out. This one did not. Okay. One more problem. This sometimes, or no, oh, I lied. We've got another page. We're getting there. So here we are. Sometimes we want to solve for a specified variable. So in this problem, we have r is equal to the square root of a divided by 4 pi, and we want to solve for a. So I'll just rewrite it so we have room to work. So what do we need to do? Good. Square both sides because we have a square root, and we need to break that a out of the square root. So r squared equals a over 4 pi. Now, if I multiply both sides by 4 pi, this divides out to be 1, and we get 4 times pi r squared is equal to a. So, of course, a would equal to 4 pi r squared. And we're done. Okay, example 4, without graphing, we need to find the x-intercept of the function. So what would your y value be or your function value be when you're crossing the x-axis? Kind of visualize that. Good, it would be 0. So in order to find the x-intercepts, you set f of x equal to 0, and then you solve the resulting equation. So at this point, you should be able to pause the movie and solve. So why don't you give it a shot? Okay, let's see how you did. I think I'm going to add the 2x and the root 2x and subtract the 1 and get them on that left side. So we'll have a positive root 2x minus 1 equals the square root of 2x minus 3. And then we square both sides of the equation, and we will get root 2x squared minus 2 times root 2x times 1 plus 1 squared equals 2x minus 3. So root 2x squared is 2x. We'll have minus 2 times root 2x plus 1 equals 2x minus 3. Now we need to isolate that radical. So negative 2 times root 2x will be alone on the left. I'll subtract 2x minus 1 from both sides. So do you see that if I subtract 2x, let me get this all on the same line. If I subtract, I'm going to show you the work on this. I think it'll be illuminating. So if I subtract 2x and I subtract 1, subtracting 2x and subtracting 1, on the next line I will get negative 2 times the square root of 2x is equal to, do you see how that's 0 x's? So I'll end up getting negative 4. And if I now divide both sides by negative 2, I'll get a positive 2 on the right side. And then I just go and square both sides, and we will get 2x is equal to 4, so x is equal to 2. And we just need to check our answer. So again, we can find, is f of 2, is that equal to 0? That's what we were looking for. So what is f of 2? F of 2 is equal to the square root of 2 times 2 minus 3 minus the square root of 2 times 2 plus 1. F of 2 is, that would be 4 minus 3 under the radical, which will be 1, minus root 4 plus 1. So f at 2 will be 1 minus 2 plus 1. F at 2 is indeed 0, so that checks. So find the x-intercept. The x-intercept is an ordered pair. So the x-intercept is the ordered pair to 0. And our last problem for the section, I bet you're so excited. A basketball player's hang time is the time spent in the air when shooting a basket. The formula t equals to the square root of d over 2 models hang time, t, in seconds in terms of the vertical distance of a player's jump, d, in feet. When Michael Wilson of the Harlem Globetrotters slam dunked a basketball 12 feet, his hang time for the shot was approximately 1.1 seconds. What was the vertical distance of his jump? So his hang time is t, right? What was the vertical distance of his jump? All right, that's going to be d. So let's check it out. We have t equals the square root of d over 2, but they told us that t is 1.16 seconds equals the square root of d over 2. I need to isolate the radicals, so if I multiply both sides by 2, I will get 2.32 equals the square root of d. Now what do I do? Good, I square both sides. So when you square the 2.32, you end up getting 5.3824 equals d. And they said to approximate d. So d is approximate to the nearest tenth of a foot. So that would be 5.4 feet. And it's nice to put the answer in words. The vertical distance of Michael Wilson's jump was approximately, we should say, because we rounded, 5.4 feet. And we are all done. I got to tell you guys, it's after 9. I am ready for a glass of wine. I hope you guys have some similar legal way to relax, and I shall be talking to you soon. Have a fabulous evening.